Yes.
Okay. The statement that I am going to assess says that the coil that we use to construct our motor can have various shapes beyond the circular shape that we use. For example, the coil can have a square shape, a rectangular shape, a triangular shape, etc. Nevertheless, this shape is irrelevant to the efficiency of the electrical motor, meaning it does not matter what shape you choose. All the quantities involved in your motor are independent of the shape you choose, and as such, how fast the coil rotates does not depend on its shape. And well, I believe that this statement is false. Now I'm going to provide an explanation of why it is false. So we can determine or we can measure how fast a coil rotates according to its angular acceleration, which is given by the following formula. Angular acceleration is equal to the torque divided by the moment of inertia. And starting from this, the moment of inertia is dependent on the mass. So if we use a particular shape, well, the mass changes. For example, the length of wire that we need to create, for example, a square is different from the length of wire that we need to do a circle. So starting from that, it will affect the shape, will affect the acceleration, because we need different amounts of wire that will have different masses. And then the torque is the result of the multiplication of the magnetic dipole moment and the cross product of it times the magnetic field. And if we analyze the magnetic dipole moment, we know that it is given by the number of loops in a coil, the currents passing through that coil, and the area of of the coil. And well, a vector that is normal to the plane of this coil. And well, this is what tells me that this statement is false, because the magnetic dipole moment depends on the area. It means that it will depend also on the shape, because we do not calculate the same area for example, for a triangle than for a circle. The areas are very different, right? The triangle, for example, is equal to 1/2 of base times height, and the circle is equal to 5 times radius squared. And also, in a qualitative way, we could see it that if the magnetic dipolar moment represents the strength of the magnetic field, then we also have to take into account how much of the magnetic field is actually in contact with the enclosed area. And well, if we have, for example, a circle like in our motor, then the magnet is here, then the magnetic field lines are passing through here, right? But for example, if we have a triangle and the magnet is here, then some of the magnetic lines will pass through here. But for example, in this part, the magnetic field is not passing through the coil because of the shape. So because of these two reasons, and this, I believe that the statement here is false.